In this video, we want to expose the concept of metric spaces. Before now, we dealt with the notion of absolute value of real numbers, from where we know how we can measure the distance between 2 points on the number line. Suppose I give A and here, and then I give B here, or however it is. We know how to measure the distance between the 2 points. And how do we do that? We simply take the absolute value of A minus B. Whatever we get is the distance between A and B. Now, we want to generalize this notion to arbitrary non-empty set. So we want to know, I want to learn rather, how to measure the distance between two elements of a given set, whether the set is a set of real numbers or any other non-empty set. And so we first begin with definition. Definition. Let X be a non-empty set. A function D defined on X cross X into the set of real numbers R that satisfies the following axioms. It's called a metric on X. What are those axioms? One, I simply write A1. Is that the D of X, Y is non-negative. With the condition dx, y is 0 if and only if x is equal to y. The second axiom is, so we call this first condition non-negativity condition. So let me write under it non-negativity condition. The second axiom is that d of x, y is the same as d of y, x. We call this a symmetric condition. And the third axiom is what we call the triangle inequality. It says that the distance between x and y is less than or equal to the distance between x and any other point z plus the distance between z and y. All these have to be true for all x, y, and z in capital X. So any function that satisfies conditions 1, 2, and 3 is called a metric on a set capital X. Here we need the Cartesian product of the two sets. So, by X cross X, we mean the Cartesian product of the set X with itself, which is what we define as the collection of elements of the form X, Y, such that X is a member of capital X and Y is also a member of capital X. If X and Y are different, for instance, if I have A cross B, we mean the collection of sets whose elements of the form A, B, such that A belongs to A and then B belongs to B. This is what we mean by Cartesian product of two sets. For instance, if I give A to be the set 1, x and I give B to be the set 0, 2, then by A cross B, we mean the set whose elements are 1, 0, 1, comma 2, comma x, comma 0, comma x, comma 2. If you observe closely, you see that there is an order that is obeyed. Elements of the set A must come first in all the elements in the set A cross B, in keeping with this the general definition we have here. So this is what we mean by a Cartesian product of two sets. Now, if A is equal to B or B is equal to A, then we have what we have here, x plus x, which we define in this form. Having taken away these definitions and we are familiar with them, because this is the set on which we build the discussions we have about metric spaces. That's why it's important to take out time, as we did, to understand what x cross x is.